What can GLLS do for me? What have they done for their clients? Why choose GLLS for my next project? These might be questions that you're asking yourself right at this very moment. Well, we could tell you that we've been providing custom solutions in the lighting industry since 2004, and that we have worked with some of the top brands in the world. But a picture is worth 1,000 words. Instead of telling you what we've accomplished, let us show you some of the many projects we have provided lighting solutions for. What can GLLS do for you? Let's walk through the full process so you get a good understanding of how it works. Starting the process is easy. The first step in bringing your ideas to life is to visit our website at glls.com and click on the Contact Us tab. Once you submit the contact form, your information is sent directly to our team. One of our dedicated account managers will take it from there. You will be contacted to get the ball rolling on bringing your exciting new design to light. We will help you narrow down which product works best for your project needs and point you to the right decision to reach your goals. After you've discussed your project with your account manager and they fully understand your vision, our highly knowledgeable technical consultants take it from there. Specially trained to know our products inside and out, they work very closely with your account manager to help with measurements, power consumption, and drawings. They are also available to field any technical questions you may have before and after you receive your proposal. We can provide DMX programming, AutoCAD drawings, LED wizard drawings, wiring diagrams, and any custom solutions you need to push your project to new heights.
Hi, my name is Derek with Green LED Lighting Solutions. I'm going to do a little demonstration on how you can manipulate the LED Neon Flex for signage applications and basic tips and tricks for using this in signage to replicate a neon sign. One of the things that I want to show is that a lot of people don't realize this, but this here, 4 inches can be basically, or 100 millimeters can be lit up as one individual light. So you can use that as one piece of light in your signage application. Another thing is, if you have a smaller sign, we have the Contour, which has a smaller cutting unit of just over 1 inch. And it can go as small as that can be one light fixture right there. So one individual piece of light. That's quite small. If you can't make a sign with cutting units that small, then we have other solutions that we make the signs, and they're basically made out of poured acrylic, where we can make the signs very small and still look like neon. Now, to manipulate these products a little bit, to work in your signage application. Okay. Now, another thing to consider is that you have to watch where the circuit board is, so you don't cut into it while you're doing this stuff. But here we go. This here is the opposite side of the circuit board, so you can do things like you can cut into the material a little ways. Take a 45 out like that, then you can come into the strip like that for different shapes. Now, this can only be done for indoor applications because water will get into the fixture from the end if it's not covered up properly. So if you are to manipulate the fixture to put together pieces like this, and it's for outdoors, you're going to have to make sure you've used a lot of silicone or some kind of material to cover this so water can't get into it. We've tried a lot of silicone. We haven't always had good luck with it. Sometimes water still gets in even with this full of silicone. So it's use at your own risk kind of deal. We won't warranty the fixture against water ingression if it's been cut up like this. So another thing that you can do too, you got a bunch of little pieces. Give you an idea of how small you can make these. Now you have to create your own. You have to create your own track system to mount this in. Usually, for most signs, the clips don't look that great. They kind of allow sag movement in between. So if you are to make a sign, you should make a channel that this fits in throughout your whole sign, even for your tight bends and whatnot. So here's smaller pieces. This is the contour, and you can put it together in fairly small shapes. Or you can do like a K. Now there's a bit of memory sticking into this right now because of the type of material that's holding the angle. The memory in the material is holding the roll shape. So like I said, you need something to you need to make a channel for the material to fit in. One way to make that channel that some sign shops are doing is that they're taking their routing machine, they're routing out black acrylic for the fixture to fit in. So then you can do something like this. You can inlay the fixture up to that point and then glue it into place, and it'll look like a nice finish. I mean, this is the only example I have because I don't have a router and or a CNC table with a piece of acrylic here, but I think you can get the idea from this. Another thing that can be done too is, aside from cutting into the material, you can cut squares out of the material a little bit, give it a better finish. Now, if you don't cut too deep, it won't affect how well it keeps the water out for outdoor applications. There you go, another tighter finish. Depending on how close your viewers are to your sign, this can be critical. Most of the time you're going to be fine with a little space like that or a little space like this. We're also working on a new connector that'll allow you to stick it in the end, and it'll basically, the wires will come out flush on the bottom. That kind of little do-it-yourself connector for indoor applications. It's quick and easy. Once that's available, we'll send information. I wish I had a channel. Now for the contour, to understand how far you can bend this. And another thing, our minimum bend radius is calculated based on putting this material in a machine that goes like this for a long period of time. And then once it breaks at a certain point, that's how we calculate our minimum bend radius. All in all, there's a circuit board in here with solder on it, and the minimum bend radius is based on when you actually can damage that. So if you do have a piece that fails from overbending it, we won't warranty that because it's actually damaged the circuit board from squeezing it too tight. But we've had lots of people with applications that squeeze this stuff right down, and it keeps working. Like I said though, it's user discretion. If you have a project like this and it's accessible, easy to get to, then by all means, I mean, try it. If it's easy to fix, if you have a problem later, it bends better. This material here will bend in on itself better than it does out on itself. So the circuit board's right there on this side. So if you have an application with a tight bend, you want to bend it in on the circuit board. And then you can kind of feel how tight it is. The reason why you want to bend it in on the circuit board is, now here's why you want to bend this in on itself. See all the little solder joints here, here, and all along the circuit board? What happens is, in this light fixture here, inside the circuit board's right there, so the LEDs are on this side. If the circuit board's, the LEDs are towards the thicker side of the opposite side of the circuit board. So what happens is, if you bend it in on itself, as you can see, you're not putting as much strain on the solder joints. Now if you bend it out on itself, you'll see that it pulls the board tight on the surface, the circuit board, and it's pushing it wants to almost push or pop the LED off. So what that's going to do is it could crack a solder joint and cause damage in the section. But that's all that happens when you overbend this material from its maximum bend radius. Like the contour, same thing. You want to go this direction because where the circuit board is. So I mean, that's a pretty tight bend radius. You can get to that. And still operate. It's a great material. Now I'm going to go over the ends a little bit. For signs that have an outdoor application, you're going to want to use, or have us make, the injection molded ends. This is critical to keeping moisture out. As you can see, it's all sealed, tight, nothing can get in there. We even have a crimp on the end to keep the seal around the wire nice and tight. Now this here, we can do it with both the contour, with the short cutting units. So we can injection mold one end, but it's only to a certain point because the machine, you have to be able to hold the strip in. So we do have some limitations on how short of a piece we can do the injection molds on. I think it's 4 or 5 inches. I'll have to double check. That's good information actually. Yep. We need to get that. So with the injection molded ends, basically you have your sign, it can come out the base, or if you router out a channel through it with your CNC machine, then you can embed the LEDs. The injection molded ends are key for that because you can have a nice clean cut on the end right here. Another thing with the injection molded ends too is that they're clear plastic, so they transmit light. So if you're up against something like this, it's going to transmit light through the end and make it look like a finished seal. So it's going to remove that little cut right there. And that's basically about it. Any questions, feel free to contact us and somebody will walk you through the process or answer any questions, the best of our knowledge that on limitation or how far you can cut into the material or when you're going to hit the circuit board. The best thing to do is just get a piece and play with it and do little things like this, notch it. Another thing a notch can do too, should add this. Another thing a notch can do too is make for a nice 90-degree bend. See? That one little notch. And it also takes a lot of stress off the circuit board. So you can actually make tighter bends.
Hey guys, Mark here from Green LED Lighting Solutions. Today we're going to pick apart some competing and imitating samples and fixtures that you're going to come across in the market. We're going to play with them, compare them to some of our fixtures in both PVC and silicone, show you some comparable products, some not so comparable products, and tries at some injection molded accessories. Stay tuned, we're going to show you some comparisons and have some fun. So we're going to compare a very popular competitor on the market. You're going to see it's a flexible LED neon in a sense. Some big differences you're going to see between our fixture and this is some exposed wiring on the bottom with some leaks, some exposed spots, and some very what we'd call poor craftsmanship in the injection mold here. Just bare wire, two wire, and something that you can basically pull apart and then get an ingression pretty easily. So leaving a lot of room for water, moisture, and humidity into the actual lead wires, not to mention the actual accessories themselves. So we can see how these are just glued on. This is actually a piece that's on top of another piece, just glued on. So you can see it can peel away, start to come apart. With time, expansion, and contraction, this is going to chip away and actually turn into an exposed airflow gap, resulting in product failures, especially in harsh environments. We are actually going to cut it open and see a difference. So I'm going to take an injection here, which seems to be a cutting unit. You can see it's a piece inside of a piece. There's actually a middle part that is outlining this. Let's cut it open and see what we're working with. So, big differences between our products is the layer inside is a separate piece, chopped up. It actually will dissect. No, this is not going to come on film very well. Let's take this apart. So, not much rigidity in the back rail. A little bit of a reinforcement backer, but no continuity between that. This is just an LED board inside. Standard SMD chip with the wires just soldered right onto the cutting unit. So pretty basic, a lot of air gaps. The big thing you see is this piece on top. There's an airflow gap. This actually reduces your dispersion It's going to actually reduce your light output. It's a big difference why we have brighter fixtures versus this American competitor. Brand new sample from another silicone neon strip. Brand new sample piece. Injection molds, as they claim. So seamless accessories. You can see by default it's a very flimsy, perforated design. Very strange feel to it, low grade. And this is where we're going to see the failures in the injection wire. So the one thing I can do right away is start peeling at this, chipping away at it, and it's already peeling itself off. So already with just that strength, the lead wire is exposed through. It's actually pulling the inside. So we're going to dissect this. Pulling the lead wire right through as a solid piece. So if I keep pulling, I can pull the circuit board directly out of this extruded piece of light. Wired directly to the light, a very small SMD, no fail safes here. So it's just a bunch of LEDs put into a strip and then put into this. So let's just chop this apart. See the insides. Pretty basic. Again, just the front of it has a exposure on the bottom, a diffused open top. You slide the LEDs inside. No backer, no copper, no reinforcement. This is a very, very cheap silicone product on the market. Supposedly IP67 grade, and definitely not going to come with very much of a warranty on this because this is leaving a lot of room for failures. No reinforcements, a very flimsy product, and very cheap LEDs inside.